Hello. So now we will study the surface potential energy. So if you remember, we studied the pressure potential energy also, because we come to know that the forces which give the pressure, they were conservative in nature. And these forces, surface forces, are not different than the forces which was causing the pressure. They are same, but we have to calculate them in different manner because they are acting within the surface. So these forces are also conservative in nature. So we have to calculate the potential energy corresponding to these forces. To calculate the potential energy, we make U-shaped U-shaped wire we take, and which is rigid wire, and upon that we create a sliding rod. And there is a surface, single surface is there here. There is a single surface. I'm deriving this only for single surface. If there will be multiple surfaces, since potential energy is scalar, if you find the multiple surfaces, you can just add the potential energy because it is scalar. So this sliding wire, we take the sliding wire at a distance x. And when it is at the distance x, it will experience the Fs force. The length of the wire is L. It will experience the surface force Fs. At that instant, we apply the external force F, which is of the same magnitude as Fs. And since if it is the same magnitude, the acceleration throughout will be 0. So by applying this F, we move this wire by a distance dx very slowly. Throughout the acceleration is 0. So by doing that, we can ensure that whatever work this force is doing onto the wire, that work is going in terms of potential energy. It is being stored in terms of potential energy. No amount of work is being transferred in terms of kinetic energy because this rod will not gain any velocity. It is moving very, very, very slowly. Okay. So now we have a general formula between the potential energy and the conservative force. So from that formula, if I write the formula is du is equals to minus of F dot dx, where this is, I'll say Fc. C stands for conservative. So potential energy due to any conservative force is calculated by this formula. Du is equals to minus of Fc dx. In this case, in place of Fc, we have Fs. So dus, the potential energy, surface potential energy, will be equals to Fs dot dx. Okay. So you see, we have to take the dot product. So that will be Fs dx multiplied with cos theta, where theta will be the angle between Fs and dx, which is 180. If you see, the dx is moving forward, Fs is acting in a backward direction. So, minus is there. So it will be Fs dx cos of pi. The cos of pi will become minus 1, minus 1, minus 1 will be positive 1. So Fs dx will be the dus. Now, if you remember, this Fs is related with the surface tension. If the surface tension here is T, then we know that Fs upon L is T. Within a single surface, obviously. So this Fs, I can write it as T into L dx. That will be equals to dus. Now, you see, this is T, this is dx. So let's integrate that. So if I integrate, T is a constant, L is a constant, I'll integrate from dx, and I'll integrate it from x1 to x2, and this I'll write as us1 to us2. We'll do the integration, and we know how to do the integration for these kind of functions. So dus will become us, limits from us1 to us2, t into L, dx will become x, limit from x1 to x2. We'll put the limits. So first we'll put the upper limit us2 minus the lower limit us1, and that will be equals to t into L, x2 minus x1. Okay. So if I multiply this L inside, it will become, and you see, Lx is nothing but the cross section area. So this whole equation will become us2 minus us1 is equals to t times of A2 minus A1, where A1 is the initial area and A2 is the final area. So US1 is the energy when the area is A1 and US2 is the energy when the area is A2. This is the general formula for surface potential energy. General formula. Okay, so let's make this formula a little bit easy. To make this formula easy, what we do, we assume potential energy 0 at some point. So in this case, what we will do, we will take assumption that when the area A1 was 0, at that point I am assuming the potential energy is 0. That's my assumption. So if A1 is 0, US1 I'm taking as 0, then when the A2 becomes A, some general area, I'm defining US2 as just US. So by putting these values, potential energy will be equals to T into area, cross-section area. So at any point of time, and this formula is only valid for single surface. So at any point of time, you can calculate the surface potential energy by multiplying the surface area with the surface tension. The multiplication of surface tension with the surface area will give you the surface potential energy for that system. Okay. And this formula is valid for single surface. If you do find multiple surfaces are there, what you will do, you will separately calculate the surface potential energy for each and every surface. And then you will take the algebraic sum. Algebraic sum means the positive surface energy you will take as positive and the negative surface energy you will take as negative, and you will just add them. Then you will get the total energy. You don't have to take the direction because the energy don't have the direction. So only the scalar addition you have to do. Okay. So thank you.